So perhaps to look at now is correlations. It's been mentioned at least once earlier in the video. So we have a correlations matrix. So if we open up this and we just hide the empty cells just to shrink the size of the matrix so you can see what's going on. So I have a very simple model where I'm using a risk on the risk register over here that represents performance of each of the work breakdown structure items. So the ground works, the main works, the design phase, etc. There's a few assumptions that are then put in as risks and things. But when we look at those in our correlation matrix, I can correlate the performance of one part of the model with another part of the model. So that's a schedule. That's a schedule to schedule relationship. So for instance, there could be a very strong relationship anywhere that's close to, like here we've got the fit out of the design is strongly correlated because it's nearly a 1.0 with the actual fit out works itself. So quite a strong correlation. So if you're having trouble with the design, you might have trouble with the performance of actually doing the work in physical out on site. And I imagine there's probably similar relationships elsewhere in this correlation matrix. If you want to start correlating things from your cost model, if I just untoggle the hide so I can now reveal the full scale of the model. So you can see that the things that it is actually capable of correlating are any of the risks pre and post mitigated uncertain values. Then there's also the cost model, and there's also it's possible to correlate things from the schedule. If there's a 3-point estimate that's held directly on the schedule, like a min likely max and a distribution, which is quite traditional, then that would also be entered in here. You'd see that as a filterable option as well, but I don't have any in this particular example. But just looking at costs, so I'm going to untoggle the risks for a moment. So we're just going to look at the costs. So these are the different things, and if we wanted to, we could start correlating how the price of plumbing might be related to the price of, and then pick something else on the matrix, or they might be inversely related. So there might be a negative correlation. So if the price of one thing is high, then the other thing might be deemed quite cheap and easy to get hold of. So that would be how you would look at correlating these things, but you can only correlate them if they have an uncertainty value. So that means it has to have one of those columns with a distribution. If it doesn't have a distribution, it can't be correlated. That's the simple sort of truth of the matter. That's the kind of the physics of it. So any uncertainty variable can be correlated positively or negatively, or if you leave it blank and empty on the correlation, then they're not related at all. So they're free to kind of behave and perform as they need to.
Now that was a bit of an introduction to the correlations matrix that we have inside Safran Risk. It's actually a pretty meaty topic, so it's probably worthy of a deeper dive video in its own right. There are other forms of correlation, of course, that aren't risk to risk, but rather one risk spread across multiple activities, or in this case with the cost module, could be one risk spread across multiple cost elements. And then you might want to explore the degree of correlation, of existence or impact, severity. So that would come up in video 27. So we explore that in greater detail there. Otherwise, up next, I'm going to be introducing an alternative method for creating delay penalties using hammocks, which is a more visual or visually engaging way of explaining to your team when those penalties are applying or not applying, etc.